Hey Matrix, welcome to the next video in the Maths Paper 1 playlist. Today we're going over question 5 of the November 2020 past paper. If you don't have the paper, then please pause the video now. There's a link in the description where you can download the paper as well as the memo, and once you have the paper you can continue with the video. Okay, let's get started with question 5. Okay, so question 5.1 says write down the coordinate of A. Okay, so note that A is on the y-axis, which means our x value is 0. Oh, I've written down the wrong thing over here. Okay, ignore that one. This should be 0 and y. Okay, so we need to now find the y-intercept. Okay, so we know that x equals to 0, so we can just substitute that into our formula. So it will be 3 to the power of negative 0, and we know that anything to the power of 0 is just equal to 1. Okay, so the coordinate for A is going to then be 0 and 1. Okay, now for B it says determine the coordinate of B. 5.2, we're finding B. Now we can see that B is in line with 9. Okay, so we have the y coordinate already, it's 9. We just have to find the x coordinate. Okay, so once again our equation is y equals to 3 to the negative x. Okay, so we have that 9 equals to 3 to the negative x. Okay, exponent rules, we can break 9 into exponent form. That is just 3 to the power of 2 equals to 3 to the power of negative x. Okay, exponent rules again, we can drop the bases, so 2 equals to x. So x is then equivalent to negative 2. Okay, so the coordinate for B is then given as B is negative 2 and 9. Okay, don't forget to write down in coordinate form. Okay, now 5.3 says write down the domain of the inverse of f. Okay, so we first have to find the inverse if you're not too sure. So finding the inverse, we let x equals to y and y equals to x. So you can note that the inverse of the function is just the reflection over the line y equals to x. Okay, so let's find this quickly. So I'm going to let x equals to y and y equals to x. So we're going to have x equals to 3 to the negative y. Now all we need to do is solve for y. Okay, so from your log rules, we know that log base 10 of x is going to equal to log base 10 3 to the negative y. Okay, by our log rules, because it's to the power here, we can take y down to the front. So we take the negative y with. So we end up with log of x. Okay, you don't have to include the 10. I'm just doing it for now. So log of 10, 3. Okay, and that comes out, which means we have negative y. Now it's just writing everything in terms of y. So this is going to be divided. So we divide by log 10, 3 on both sides, and we can take the negative over. So you should get y equals to negative log of x all over log of 3. Okay, so we've got a log function, two log functions being divided. You can write it as log x minus log 3 if you want to, but I'm going to leave it in this form. Okay, so we're dealing with a negative log function, so it's going to look something like this. Okay, and we can see that it's from the y-axis to infinity, so the domain is going to be where x is an element excluding 0 and excluding infinity. Okay, now looking at the next question, it says describe the translation from f to h of x. Okay, so I've given you the formulas here. F is 3 to the negative x, h is 27 over 3 to the x. Okay, so we can see that f of x, okay, can be written as this to the x. So we can see that h of x is just multiplying f of x by 27. So technically h of x equals to 27 times f of x. Okay, but remember 27 can be written as 3 to the power of 3. Okay, so now we want h to look like f of x so we can describe the transformation. Okay, so this is then going to be equal to 3 to the power of 3 times 3 to the negative x. Okay, so we know from our rules, if it's multiplying and they have the same base, we add the exponents. So that's going to then equal to 3 to the power of 3 minus x. Why? Because positive times a negative equals a negative. Okay. But now I want this to look like my function up here, so I'm going to take out the negative. So 3 to the negative x minus 3. Okay, so now that we have that, we can describe the translation that has taken place. So remember from our rules of functions, if I have x minus 3, okay, or x minus or plus something over here in a bracket, we're looking at how the x values have shifted. Okay, so we can see that because it's a minus, the x-axis has shifted, or every x value is shifted to the right by 3 units. Okay, so you can then say that f of x shifted 3 units to the right. Okay, and that's how we do that one. Now looking at 5.5, it says determine the values of x for which h of x is less than 1. Okay, so we have h of x now. H of x is given, so 5.5. H of x is equal to 27 all over 3 to the power of x. Okay, or we can write it in the other form that we have it, which is h of x equals to 3 to the negative x minus 3. Okay, and we want to know where is this less than 1. Okay, now again, your exponent rules, remember anything to the power of 0 equals to 1. So I'm going to rewrite this 1 with a base of 3. So I'm going to have 3 to the negative x minus 3 is less than 3 to the 0. Okay, now that I have the same bases, I can drop the bases and just work with the exponents. So I'm going to have negative x minus 3 is less than 0. Divide both sides by a negative, which means my sign swaps. So x minus 3 is greater than 0, which means x must be greater than 0. Okay, so to answer the question, for which values of x will the function be less than 1? Okay, it will be less than 1 for all... Oh, my bad, I'm sleeping here. It will be for where x is greater than the value of 3. Okay, and that's how we go about doing this question. Okay, if you found today's video helpful, then please leave a thumbs up on the video. If you have any questions regarding this question, then please leave them in the comment section down below. I'll get back to them as soon as possible. Please go check out the channel. There's also physics, chemistry, and maths paper 2 videos over there. And while you're there, consider subscribing. And remember, it's never too late to have an OIC moment.